So, what if a biologist, an astronomer, and a business strategist could all speak the exact same language? I'm not talking about for small talk, but for the actual act of discovery itself. Today, we're digging into a really fascinating idea, a proposed universal grammar for inquiry called ULI. It's designed to tear down the walls between different fields and completely change how we solve problems. All right, here's how we're going to break this down. First, we'll look at the big problem ULI is trying to solve, this whole idea of specialized fields. Then we'll get into the grammar itself. After that, we'll see some pretty mind-bending examples, redefine what it even means to be an expert, and finally, look at how this could be a kind of operating system for thinking. To really get why a universal language for discovery could be such a game changer, we first have to understand the problem it's designed to fix. Let's just kick things off with a big question. Does becoming an expert actually make it harder to discover new things? The whole idea behind ULI suggests that, yeah, in a lot of ways, it really does. This trap has a name, the Mobius loop of knowledge. Think about it. We're often taught that there's one right answer to a problem. Once we learn it, our job kind of becomes defending that answer. And this creates these disciplinary silos that are fantastic at protecting what we already know, but maybe not so great at generating brand new breakthroughs. And here's the problem in a nutshell. What we learn in the classroom is often super linear. A plus B equals C. Done. But real discovery, man, that's a whole different animal. It's messy, it's divergent. It's not just about finding C. It's about exploring the possibility of D and E and a whole universe of outcomes we can't even predict yet. Our systems just aren't always set up for that. Okay, so if we're stuck in this loop, what's the escape hatch? This brings us to the proposed solution, a unified language of inquiry, or ULI for short. ULI is meant to be a simple grammar for discovery that works no matter what field you're in. So think of it less like a subject you have to master and more like a universal recipe or an operating system that anyone, anywhere, can run to explore a problem. And what's really striking is just how simple this grammar is. It's built on just 4 core actions, or operators: R, delta, S, and X. This 4-step process is the engine that drives discovery in the ULI framework, and it's designed to flow together as one continuous motion. So it all starts with R for directed randomness. I love this. You can think of it as your noise budget. You deliberately, intentionally inject a little bit of chaos into your process, say 10 to 30% worth of random changes. Why? To shake yourself loose from your own assumptions and get off the beaten path. Now, once you've got that randomness going, you bring in delta for intended deviations. This is key. You don't just stick to one way of looking at a problem. You actively force yourself to explore it in 2 or 3 different ways at the exact same time. You might build a visual model, look at the raw data, or even, and this is a real example we'll see, explore it through smell. Okay, so you're exploring all these different angles. How do you know when to stop and move on? That's where S for saturation comes in. This is your crucial stopping rule. It's that point where you hit diminishing returns, when adding more noise or trying another perspective just isn't giving you any new insights. That's the signal. And that signal moves you to the final and maybe most critical operator, X for exit thread. This is a clear-cut pass or fail test that you define before you even begin your inquiry. It forces an outcome. You either pass the test or you fail and go back to the drawing board. It's designed to kill endless debates in meetings. So that's the theory. Sounds pretty cool, right? But what does it actually look like in practice? Let's check out how this one simple grammar can be applied to some unbelievably different problems. Get this example from ecology. The goal here is so clear, and more importantly, it's testable. The exit, the X test, could be a measurable drop in water temperature. See? It's not some vague mission statement, it's a specific, falsifiable outcome. Or what about this one? Using OUI to model a city's smellscape as a language. The delta here is just brilliant. You're representing the problem through human descriptions, an electronic nose, and even image patches all at once. And just to show you the insane range of this thing, here's an example from astroecology. The goal is to get past a simple yes or no answer for cosmic dust. The exit test here demands a proven link between different signals that holds up for a full 12 months. Now that is what rigorous, repeatable inquiry looks like. Seeing these examples really brings up a powerful idea. If anyone can use this grammar on pretty much any problem, what does it even mean to be an expert? The traditional expert, let's call them expert version 1, is a possessor of facts. Their value is locked up in the knowledge they've collected inside their specific silo. They're the person who's supposed to have all the answers. But the ULI expert, or expert version 2, is a completely different breed. They are an exit architect. Their skill isn't knowing a bunch of facts, it's being able to build reliable, reproducible tests, those X's, that can cut through ambiguity in any domain, even one they know absolutely nothing about. Their expertise is portable. This brings us to the big takeaway. ULI isn't just an academic thought experiment. Let's zoom out and see how it could work as a practical, real-world operating system for thinking. Because this framework makes the whole process of discovery something you can actually measure. Each of the 4 operators can have its own key performance indicator. You can literally score how well you're exploring a problem based on stuff like your noise level or your exit success rate. You can apply this directly to business. Instead of sitting through endless slide decks and strategy theater, a company could actually run ULI. The market hypothesis is your intent. You set aside a budget for random wildcard experiments. You run 2 different strategies in parallel. You watch for when customer feedback starts to plateau, and you have a hard, predefined exit gate, like a specific revenue target. It makes strategy an actual experiment. And that's really the ultimate promise here. ULI isn't about getting rid of different fields, but it's about giving us all a shared, portable operating system for curiosity. It empowers anyone to conduct a really rigorous investigation, whether they have a PhD or not. So this leaves us with one final thought. If you had this simple, powerful grammar for discovery, something you could apply to a business challenge, a scientific mystery, or even just a personal decision, what problem would you solve first?